Number 1. Scoot over here. All right, number 1. 1 over 8x plus 8 plus 1 over x equals 1 over 12x. Yeah, we are going to do a lot of word problems here, but you know, a large portion of this too is just solving equations, and maybe this is one of the more challenging ones to do. We come across one like this. What do? Well, first of all, with the denominators, if you got factorable denominators, do that first, right? We want to factor any denominator we can, and we can factor 8x plus 8. How so? Yeah, you can pull out an 8, GCF of 8. So we're going to pull out that 8. That'll leave me x plus 1. The others, well, the others don't factor, so I'm just going to leave those as is. And we do that because then we can say here the LCD what it is. Of course, we need, for the x's, we need a factor of each kind of x. So we got an x plus 1. And of course, the x plus wouldn't cover the x. We need also a factor of x, wouldn't we? Because that's a different factor than x plus 1. So we also need a factor of x for those to represent those two. And then I have the 8 and the 12. Now I'm looking for a multiple of those, both of those go into 24. Okay, so 24 would be a multiple both of those go into. So 24x, x plus 1 is going to be the LCD. And what do I do with that LCD? Well, I multiply the LCD by all the parts. So I take the 24x times the x plus 1 times 1 over 8 x plus 1 plus 24x x plus 1 times 1 over x, and then 24x x plus 1 times 1 over 12x. And that ought to... Yeah, write it out so we can visualize the cancellation. So x plus 1's cancel, the 8 and the 24. 8 goes into 24. So 24 is on top, so that's 3 left there. And so nicely we have 3, and don't forget that x, and then 1. 3 times x times 1 is 3x. 3x is all that's left here. What happens here in the middle? Well, just the x's cancel, so I have 24 x plus 1 times 1. Well, 24 times x plus 1 would be distribute 24x plus 24. And then last but not least, the 12 goes into the 24, 2. And then the x's cancel, so I have 2 times x plus 1. That's 2x plus 2. Yeah, so now I just have a regular linear equation to solve. Do that, and that'd be 27x plus 24 equals 2x plus 2. And then subtract my 2x, subtract 24, 25x equals negative 22, wouldn't it? I'll do that right? Like so. All right, divide by 25. X is negative 22 25ths. Now, I circled that, but one other thing. To mention is with the rationals, remember, possibly you're talking about an excluded value. What do I mean by excluded value? Just to review that. A value that what? Makes the denominator 0. I think we're safe with negative 22 25ths, but just to make sure, yeah, you got negative 1 would make this denominator 0. 0, of course, would make those denominators 0. So those would be excluded. So negative 22 25ths is not, so we're okay there. All right? Anything question-wise on that? All right, 2A. We've got R equals E plus NE over N. And then we're going to say E is 700, big E is, and big R is 16. So little e is 35, and big R is 16. All right, so we're given 3 of the values. We want to find the N value then. So, of course, we want to substitute those in. R is 16, E is 700, and little e is 35. Now, probably haven't encountered this a lot, but n times 35 is... Huh? Oh. Sorry about that. Thank you. Yeah, we don't know little n. I put in the little e. All right, so, but anyway, here, the N35, that's 35N. Don't let that at all fool you there. So we just change it over, be less confusing probably. But then the other thing is, what about this? How do we go about solving this? Well, you can look at it a number of ways. Probably the easiest way to look at it is this n being in the denominator. I need to fix that, so to speak. And you can do that a number of ways. Does anybody have any thoughts? Multiply by n, okay? Yeah. If you think of it in terms of the LCD is n, just multiply by n, both sides. So that would be 16n equals, because that will cancel that n out. That is one way you can see it. There's another way of thinking. You could think of 16 as 16 over 1. Just to mention it here. And then you can do cross multiply. 16 times n equals, and it'd be the same thing, wouldn't it? Okay. Either way you go, you got the same thing. All right, so then we get minus 35n both sides. Be negative 19n, right, equals 700. Divide by the negative 19, and n is negative 700 over 19. All right. Now the other type of problem we did on those was like 2b. Same formula. R equals E plus NE over N. If I solve that for E, though, I don't have numbers to plug in, so I just have to leave all the letters in there. Work around that. But as far as solving for E, that just means get E on a side by itself, right? The little e. So how would I do that? Basically the same way as I did that. Either multiply by n, cross multiply, whatever you want to think there. Multiply by n both sides, so we get Rn equals, n's cancel, E plus n little e. Again, I'm trying to get the e by itself, the little e by itself. So this term, first of all, needs to go over there. Subtract it. Subtract e. So I have Rn minus e equals, that would leave me n little e over here. And that's n times little e, isn't it? So what would I do with the n? Divide by n. Rn minus e over n equals e, little e. Rn nr, no. That could be nr, sure. Yeah, I did that the other way there. Okay? All right? Good. 3A. 3a has 5x minus 3y equals 21. 9x plus 8y equal 11. Yeah, it's a little system. And we know a little bit about those now, don't we? Solve by a couple of methods we've got for solving. This one is more set up for which one? Elimination method, yeah. Solve this one by elimination. And on elimination, we want to eliminate the x's or the y's by basically make them the same number, opposite signs. So which ones does it look like here? I mean, it doesn't matter which one, but maybe easier to do which one? The y's, yeah. Because what we're going to do is the least common multiple of the y's or the x's. Least common multiple of the 5 and the 9 would be 45. Least common multiple of 3 and 8 is 24. So I'm going to choose to eliminate the y's for that very reason. So yeah, we're looking at LCM y's for the y's is 24. And then the other thing is there are already opposite signs, so I don't have to worry with that. If I did the x's, I'd have to make one of them negative. All right, so what do I do to my things here? On the top, I need to make it 24 minus 24, so that's going to be multiplied by 8. So I'm going to multiply on both sides by 8, the whole thing by 8. That'll be 40x minus 24y equals, and then, like I said, don't forget, that also gets multiplied by 8. The 21 times the 8 is 168. Then on the bottom, need to make that 24, so that's multiplied by 3. So that's 27x plus 24y equals, and yeah, multiply that by 3, that's 33. Add them up, that's 67x. The y's cancel equals, well, it equals 201. Yeah, so then we've got x, don't we? Divide by 67. Isn't that 3? But are we done? We're not quite done here because on a system you need an x and you need a y. There's two parts to the answer. You need an x and a y. How do we get the y? Plug it in. Yeah, plug in x to be 3, either one. So I'm going to go with 5 times 3 minus 3y equals 21. It's 15 minus 3y equals 21, so subtract 15 and divide by negative 3. So we've got x is 3, negative 2. So if we write as an ordered pair, that would be a 3 and a negative 2. All right. Which one is, well, let's write it up here first. 3b is 5x minus 4y equals negative 2. Y equals 2x plus 5. This one's more set up for substitution, isn't it? Because we've got y equals 2x plus 5 on the bottom. Yeah, this is saying y is equivalent to 2x plus 5, so I can take that 2x plus 5 and substitute it, can I, for the y up in the other one. So I'm going to substitute for my y up in the other one. So that's 5x minus 4 times 2x plus 5 now equals negative 2. Just a little bit of distributing. Distribute the minus 4, so that would be 5x minus 8x minus 20 equals negative 2, which gives me negative 3x. 5x minus 8x minus 20 equals negative 2. Add to the 20 there, both sides, and negative 3x equals 18. So again, divide by negative 3. X is negative 6. Also need the y, so substitute x to be negative 6. And that would be negative 12 plus 5, which is negative 7. How about that? Sound okay?